In our universe, there's a very distant cluster of galaxies with the unremarkable name Able 3667. It is located 730 million light-years from Earth, and in fact, consists of two galactic clusters. Once, even before the time of the dinosaurs a billion years ago, these clusters decided to merge their 550 galaxies into one large group. It banged so much that a shock wave of plasma and tiny particles is still moving through space at a speed of 1,500 kilometers per second. Just in case, this speed is enough to fly from the Earth to the Moon in 4 minutes, and to Mars, less than a couple of days. The length of the shock wave formed from the merger of two clusters of galaxies is just 6.5 million light-years, only 60 times the diameter of our home galaxy, the Milky Way. And this monstrous shockwave that annihilates everything around has been traveling through space for at least 200 million years. Scientists call the wave around Able 3667 the strongest energy event since the Big Bang. What do you think would happen to the Earth if it fell under such a wave? In fact, this is a rather difficult question. We're constantly having troubles from supernova explosions and other universal cataclysms. Their influence is known as cosmic rays, or cosmic radiation if you prefer this name. The Sun plays a big role in protecting us from them, creating a semblance of an atmosphere inside the system that protects the Earth and other planets. The second factor that saves us is our own atmosphere, which slows down the remnants of deep space particles that do reach the Earth. But one way or another, even the attempt to realize the immensity of this deadly shockwave makes us feel uncomfortable. After all, our Earth is not even an atom in the standards of space. It's something much smaller. Entire superclusters of galaxies crash into each other before our eyes. And in this regard, the safety and sustainability for life of our blue marble looks like zilch. In the next couple of minutes, we'll talk about this and estimate hypothetical scenarios of the apocalypse not related to epidemics or wars. After all, there are enough threats in space that can wipe us out in a nanosecond. The first candidate for the apocalypse is a supernova. So far, scientists assume the existence of two types of them. It can either be an old, massive star that ran out of fuel and exploded under its own weight, or a small white dwarf, which has got too much matter from a neighboring star and is exploding from the impossibility of processing this matter properly. A supernova explosion is a beautiful event. For example, it's believed that the Crab Nebula is the remains of such a kaboom. If a supernova explosion happens relatively close to the Earth, then there's a chance of seeing it even in the daylight. This, for example, happened to our Australopithecus ancestors 2.5 million years ago, or with Johannes Kepler, who observed a supernova explosion in 1604. Not so long ago, in 1987, the explosion of supernova SN 1987A was also visible to the naked eye from Earth. Its remains still can be seen today on the outskirts of the Tarantula Nebula, even though the brightness has fallen since then. But what will happen if a supernova explosion does happen not nearby, but in close proximity to the Earth? Here lies the scenario of a possible apocalypse, albeit with minor reservations. There has long been a heated debate among paleontologists that mass extinctions in the history of our planet could easily have been caused by supernova. Indeed, we're talking about an explosion of insane properties. The pioneer of the idea is Günter Korchnek, who found a large amount of iron-60 and other supernova remains in Earth excavations. That means that some substances from these explosions reached our planet. The question of its influence is still open, but our business is calculations only. And they say that the apocalypse due to a supernova is quite possible. The guys from Harvard long time ago have calculated a kind of red line of threat. It's located at a distance of 50 light-years. Supernova that are further are relatively safe for us. Everything that's located closer will definitely give us flow of radiation and ionized particles rushing at near light speed. Roughly speaking, the Earth seems to be blown over by a breeze. And depending on the strength, it can turn our planet into a stone like the Moon. Or, in a relatively good case, just irradiate us with an insane amount of radiation, making a huge part of the Earth uninhabitable. The good news is that there are definitely no stars of the first type of potential supernova within a radius of 50 light-years. We're talking about supermassive old giants. They're bright enough to see through a telescope, and it is almost impossible to make a mistake here. The classic example is Betelgeuse. This old lady is indeed a prime candidate for supernova. By astronomical standards, this will happen very soon. And then, an incredible spectacle awaits Earthlings in the night sky. Well, and in the dark sky as well. After all, Betelgeuse will shine brighter than the moon. Fortunately, you don't have to pay for aesthetic pleasure with health. The star is 642 light-years away, more than 10 times the safe distance. And there are definitely no such giants within a radius of 50 light-years. Otherwise, in the night sky, we would see them very clearly. The situation is much worse with the second type of supernova. White dwarfs are called so because they're very dim. And if we're talking about binary systems where such a dwarf revolves around a large star, to detect it is even more difficult. For example, a potential candidate for a supernova is IK Pegasi b. This tiny little thing is almost invisible against the background of the parent star and revolves around it at a distance closer than Mercury from the Sun. IK Pegasi b eats the matter quite actively and sooner or later will bang. The good news is that this is happening at 150 light-years, which is 3 times the dangerous distance. On the bad side, scientists can't guarantee that we've explored all white dwarfs within 50 light-years, and we can't even guarantee that they were all found. Therefore, in theory, the blast can happen in the red zone at any second. Even the chance is not so big, because space, whatever one may say, is very empty, and in terms of its volume, there are few stars in it. However, according to the calculations of Mark Reed from Harvard, if a supernova explodes within 30 light-years, we will face the threat of global extinction. X-rays will just roast the Earth. Along the way, they will batter the ozone layer, which will cease to protect against a similar threat emanating from our native sun. Add to all these an inevitable mutation and incredible damage to the oceans that produce most of the oxygen, and the situation will turn out to be not bright at all. Summarizing the possible apocalypse from the supernova explosion, we can say possibly, but unlikely. Let's move on to the second scenario. It's very popular and consists in the slow fusion of our Milky Way galaxy with the Andromeda galaxy. First of all, you should not succumb to the relaxing meaning of the word fusion. In cosmic terms, it's about a collision, and we have already told about the shock waves that they cause. This scenario is dangerous only because the meeting of the Milky Way and Andromeda is not a hypothesis, but a reality. In broad sources, you can most often read information that before the collision we have several billion years. But in reality, this is only partly true, because Andromeda and the Milky Way have already touched each other. Collisions between nuclei and high concentrations of matter are still far away, but galaxies have peculiar halos, areas of gases and plasma surrounding them. They extend over vast distances around galaxies. And the truth is, we don't know the exact numbers. After all, these clouds of gas and plasma are very, very dim, and it's so easy to miss them. Within the Amiga project, the spectrograph of the Hubble telescope was involved, and it showed that in some directions, the clouds of gas in the Andromeda galaxy extended as far as 2 million light-years. In the direction of the Milky Way, Andromeda's halo stretches out to about 1.3 million light-years. In the matter of fact, that's half the distance between galaxies. And our Milky Way also has a halo. And many scientists are already saying that the halo of 2 galaxies touched many years ago. Therefore, Andromeda already influences us, and we influence it. But how deadly is it? At first glance, not much. After all, space, as we have already mentioned, is very empty. For example, if the Sun were the size of a coin, the closest star to it, Proxima Centauri, would be 718 kilometers away. Imagine that there are a lot of such coins, and they make up the Milky Way galaxy. And on the other hand, Andromeda is approaching, the coins of which are also kilometers apart. What is the chance that some coins will eventually collide? Well, it's not so small, because there are 400 billion stars in the Milky Way, and Andromeda has twice as many. According to the theory of probability, somewhere, something will surely collide. But again, the chance for our particular sun is still small. This version of the apocalypse is generally possible, but firstly, it will not happen soon. And by that time, the sun will also absorb Mercury, Venus, and will already make Earth uninhabitable or will also devour it. However, there are exceptions. Stars don't have to crash into each other. They just need to fly close enough to gravitationally affect each other. And what will happen to the Earth if the sun has a girlfriend? Only Elon Musk knows. Even the slightest changes in the orbit of our planet can lead to unpredictable consequences. But in general, we dismiss this version of the apocalypse as very remote. And let's move on to the good old end of the world, which can happen at any second. Bursts of gamma rays. They happen in the universe less often than supernova, but in unpredictability and murderousness, there is nothing to match them at any chance. After the Big Bang, gamma ray bursts are the brightest explosions in the universe. Only because such bursts create ripples even in space-time. Have you heard of gravitational waves? Their discovery has become the main event of the last decade in the world of science. To detect these waves, expensive laboratories like LIGO were built. And roughly speaking, that gravitational waves are the consequence of gamma ray bursts. They also have two types. Some explosions happen with super powerful supernova, which are 100 times brighter than ordinary ones, and others have long been a mystery for scientists. But now, it is believed that the second source of gamma ray bursts is collisions of neutron stars, tiny but incredibly heavy objects that periodically form black holes. Unlike a traditional supernova explosion, a gamma ray burst most often has the form of a directed beam and does not diverge in all directions. Actually, these rays can reach tens of trillions of kilometers in width, and they can cover with a margin the entire solar system. Everything that falls under this beam is threatened with a sad outcome, because the energy released during a gamma ray flash can periodically exceed the total energy that our sun will generate during the entire time of its existence. You don't want to get under such a ray, would you? According to scientists' calculations, if something like this takes place less than 6,000 light-years away, the Earth will at least face global extinction. Mainly, this will affect the hemisphere directed towards the flash, but the ozone layer will be lost. The levels of radiation will be beyond limit, and the effect will still reach the second half of the Earth. Fortunately, the closest candidate for a gamma ray burst is now considered the star Eta Carina, at a distance of 7,500 light-years. Due to its brightness, it's the most distant star that can be seen with the naked eye. Eta Carina radiates as much energy in 1 second as the Sun manages to do in 2 months, and is a likely candidate for hypernova. We are very lucky that in the event of a gamma ray burst, most likely it will not be directed to us. But if it were, then even from such a distance, the equipment on the hemisphere that fell under the blow would instantly turn into a brick. We would lose half of the ozone layer and would receive much less light from the sun. And together with radiation, we would get a global ice age. How often do gamma ray bursts occur? Scientists record in the part of the universe visible to us, on average, 1 per day. But referring to the imperfection of the equipment, they consider the real figure something around 400 to 500. On the scale of the universe, this is of course very small. But do not forget that we're talking about a beam, which is the equivalent to an explosion of a nuclear bomb over every 2 square kilometers of the Earth. The destruction from gamma ray bursts is beyond our understanding, as is their nature. Therefore, it's not so much to be afraid, but it's worth keeping in mind such bursts. And this is another one of the scenarios of the apocalypse. Summarizing these 3 scenarios we've described, we can notice some patterns. Yes, almost all threats from outer space are very unlikely. And we also won't mention asteroids. The chance of encountering them even when flying through the asteroid belt is no higher than finding a second sock a week after purchase. But still, space is a place of frightening amounts of energy and billions of different ways that can destroy life on our planet in a matter of seconds. Let's hope that someday, humanity will understand that a person born in one country, according to cosmic standards, does not differ from a person born in another. And maybe someday, we'll start working on problems together. Until we meet again, friends.